presentation on gel documentation system. This is the gel documentation system. It consists of an imager and the software. Introduction. Gel documentation is also known as GelDoc system, gel image system or gel imager. It is widely used in the field of molecular biology laboratories for imaging and documentation of nucleic acids separated by agarose gel electrophoresis and proteins separated by polyacrylamide gel electrophoresis or SDS page. Generally, a GelDoc is composed of UV light transilluminator, a hood to shield external light source, and camera for capturing the image. Principle of fluorescence with fluorescent staining of nucleic acid. For example, ethidium bromide is an intercalating agent as well as a fluorescent dye. Ethidium bromide binds to nucleic acids by intercalating in between nitrogenous bases of DNA and emits fluorescent light due to excitation by UV irradiation. Ethidium bromide binds specifically to nucleic acids and the amount of bonding depends upon the molecular weight and concentration of nucleic acids. What is GelDoc system? The GelDoc system supports multiple applications including ChromaSip and ethidium bromide staining, blue excitation for non-destructive DNA visualization and stain-free gel imaging. The GelDoc system is a reproducible and fast label-free SDS page or native page system that eliminates time-consuming staining and destaining steps. UV transillumination versus GelDoc system. GelDoc system is used for determination, quantitation and analysis of proteins and nucleic acids in gels and on membranes. These gel documentation systems have advanced software providing rapid automated data acquisition, analysis and validation. Advanced 4 sample trays are available for GelDoc imaging system, namely UV tray, white tray, blue tray and stain-free tray. Image Lab software runs automated protocols on GelDoc EZ system for routine gel imaging, documentation and analysis. Gel documentation system are unique stain-free imaging technology allowing rapid visualization of proteins on gels and blots without staining and destaining. Designed for automation and ease of use, the user interface consists of a set of 4 sample trays and a one-touch button to image your gel using a protocol. Configuring the system. Steps for configuring the system are: first, install the Image Lab software on computer. Next, connect the GelDoc EZ imager to the computer. Next, configure the image. The components of gel documentation system. A picture has been shown on the left hand side. The components will be explained now. First component is camera. Ultraviolet camera ranging from 1.4 m to up to 8.3 megapixel is used. Lenses. All lenses are computer controlled and motor driven. Here lenses automatically tracks upwards or downwards movements of sample onto focus. Filters. There is an extensive range of filters used for an array of applications. Next, overhead illuminator, white, ultraviolet light and LED lighting options are available. Next, visible light. For extending the transmitted light application, visible light converts the screen for visible light application. Next, adjustable stage. This enables the samples to be moved close to the camera. Next, A dark room. Dark room is suitable for advanced chemiluminescence, fluorescence and visible light application. And electronic auto lock door with security functions prevents interruption to long exposure. Next, trans illuminator. It has a variable intensity setting and has a safety cutoff. The image lab software and its features. So features of the software are quantification, imaging process overview, molecular weight assessment, 2D and 3D imaging, HD quality pictures. This is the analysis tools, gel display options, zoom in, zoom out, fit in window option, image transform, change color option, switch to 3D view, image info. Also, analysis tools include tool images which enable to flip, rotate and crop images and to transform the image files, lane and band controls, the detection function enabling you to resize, adjust and bend lanes and to detect, adjust, add or delete bands. Molecular weight analysis tool enables you to choose standard samples, assign standard lanes and choose a regression method. Quantity tools enables you to automatically quantitate bands either using relative or absolute values. Annotation tools are useful for drawing attention to any area of gel of interest. Volume tools enable you to manually quantify an object inside the boundary that you define. This is the 2D and 3D imaging of a gel. Purpose of gel documentation system: protein gel documentation, nucleic acids documentation, 2-dimensional and 3-dimensional documentation of proteins and nucleic acids can be done. Gel documentation or gel imaging systems are used to record and measure labeled nucleic acid and proteins in various types of media such as agarose, acrylamide or cellulose. Monoclonal and polyclonal antibody binding affinity studies can be done. Gel and blot imaging techniques can be studied. Immunoassay can be done. Multiplex protein detection, post-translational modification, characterization and protein quantification can be done with the help of gel documentation system. We have done agarose gel electrophoresis. We have separated our DNA bands on agarose gel. Now we will place the gel on the UV trans illuminator. This is the UV trans illuminator. So first we will open the lid of the UV trans illuminator. Now we will place the agarose gel on UV trans illuminator. We have now placed the gel on UV trans illuminator. We will close the lid. Now there are two buttons. This is the UV lamp button and this button will adjust the wavelength. There are two wavelengths, 254 and 365 nanometer. If the bands are not seen at 254 nanometer, they can be seen at 365 nanometer. So with this button you can set the wavelength. With this UV button we can either switch on or off the UV light. So now I will switch on this UV button. So the bands are now seen. DNA bands are now seen under UV trans illuminator. Now we will now switch off the UV light. We will open the lid and now we will place the gel place the gel into the UV tray for further gel documentation. gel documentation, there are two trays which are available to us, UV tray and white tray. UV tray is used for documentation of nucleic acids by agarose gel electrophoresis, and white tray is used for documentation of proteins by using SDS page or native page. There are two more trays, blue tray and stain free tray, which are also used in gel documentation system. We will now show the operations with UV tray. Place the agarose gel on UV tray. Now this tray will be added into the imager. Now gel documentation system consists of two main components, the GelDoc EZ imager and the software. This image lab is the software for gel documentation, and this is the EZ imager of gel documentation system. It is from Biorad company. This EZ imager system creates an image of the agarose gel. Now we will place this UV tray into the imager. So first we start with opening the lid, then we will place the tray inside. We will close the lid. We will switch the main supply. The imager is now on. Now we will do the further documentation on this software. We will first open the image lab software for gel documentation. The startup page appears. It has protocols, recent protocols, image files and recent image files. Click on new. There are many options done during protocol setup. The first one is gel imaging. Next is band and lane detection. Next is analyze molecular weight. Next is specify output. These are the 4 protocol setup options. We will first click on gel imaging, then select on the right hand side, select nucleic acid gels, ETBR, ethidium bromide. Click ethidium bromide. Next we will see the image exposure. Image exposure will give exposure for either intense bands or for faint bands. Exposure time for intense bands and faint bands is optimized differently. For intense bands, the exposure time is optimized for all bands, whereas for faint bands the exposure time is optimized for faint bands, but the prominent bands will be overexpressed. We can choose any options amongst intense bands and faint bands. Next, we manually set up the exposure time. The exposure time has a range of 0.01 seconds to 10 seconds. We can manually set the exposure time. Later on, the next step is to go for display options. There are two options under display: highlight saturated pixels and image color. Highlight saturated pixels and image color. Highlight saturated pixels will show how much of the gel image is saturated. Image color, there are various image colors available like gray, ETBR, Comase, stain free, SYBR green, Cypro ruby, flamingo, silver, false color, spectrum, gold, silver. We can choose any of the color. We choose gray color. Next, we can analyze image. We can analyze the lane and band. So we can do lane and band detection. There are three options: low, high and custom. When you click on low, it is better for prominent bands. The sensitivity is better for prominent bands. High is better for faint bands. The sensitivity is better for faint bands if we click high option. Next option is custom, where we can select a numerical value right from 1 to 100. 25 is for low sensitivity and 75 value is for high sensitivity. So any value between 1 to 100 can be selected. Next, we choose analyze molecular weight option. We can analyze the molecular weight by two methods: either automatically, or we can estimate the size of the molecules in the bands of our gel by entering the standards, which is shown on the right hand side. First, we can click molecular weight standards. These are the various DNA standards, molecular rulers or standards available for us. We can choose either of them. Then we can add the number of lane in which we are going to add the standard. Here we have typed first lane, so the standard will be added in the first lane. Next is regression method, which is used to calculate the molecular weight of unknown bands. Next option which we will choose for protocol setup is specify output. We can specify output automatically to create a print image or to report the print, or we can also display our report. We can also add a custom title to our report. This is all about specify output. Now we are just going to do gel imaging. We are not going to perform lane and band detection, molecular weight analysis. We will just take the image of the gel and we will choose for automatic molecular weight detection method. Again, we will select nucleic acids, ethidium bromide. For gel imaging, we will choose intense bands. We will choose the image exposure for intense bands. We can manually set up the exposure time. We can set the color gray. We will keep the highlight saturated pixels open option. We will run the protocol. This is the gel image obtained. Now we can change the image color. We can keep it gray or ethidium bromide, or we can add Comase color, or we can add stain free color. We can add Cypro Ruby color. We can also add Flamingo color. We can also add silver color, false color, spectrum, gold, silver, pseudo. Any colors can be chosen. We will choose gray for now. Gray color is chosen. We can take a three-dimensional image. We can create a three-dimensional structure of our image. We have to just move the cursor to get a 3D image of our gel. We can move the cursor to adjust the area of the gel. We can straighten it. If we re-click on this switch to 3D option, then we will get back to our two-dimensional structure. We get image info or image information about the gel. We get different image details, exposure time, application. Also, we can get an image info of the area of image, image pixels, pixel size, data range, etc. So a detailed image will be created. So image info gives the detailed image information. We can take a snapshot. So we click snapshot, then we click on save it to the file on our desktop. We will save the image on our desktop. We can see the image of on our desktop. This is the snapshot of the image which we have obtained. We get back to our gel. We can go to file option and click export. So this option is useful because we can export the image of our gel to any publication. We can export the image of our gel for analysis, or we can export the image for PulseNet. We can do so by sending the image as 16-bit TIFF file. We can also send the gel for analysis, where the image size will be reduced to 8-bit TIFF file. For gel to some publication in a 16-bit TIFF file. We can also export the image for analysis. This will reduce the image to an 8-bit TIFF image file. Resolution is limited and file size is restricted to 300 KB. We can now choose the image tools options, where we can make our gel horizontal or we can make it vertical. We can rotate it to 90-degree left, or we can also rotate it to 90-degree right. We can also crop our image. If we crop with the help of a cursor, by moving the cursor we can crop the image. This is the lane and band option. Molecular weight analysis tool can also be selected for molecular weight analysis. We can view our image as transform image. So this transform image option is important. We can transform the image. Transform image option will help us to adjust the brightness and contrast of the image, and also it will display the faint details of the bands. We can select gel display options, which will display the details of our gel. We can see the image overview. We can see the image transformed. We can save the image on the desktop. We can use save or save as option. We can report the image. We can report the print preview of the image. This is the print preview of the image. The report of print preview of the image can be seen, which will give us the information of about the image, analysis settings, etc. We can see the operation history. Whatever operations we have done can be seen. Many more operations can be done on the gel documentation system. For example, we can find out the intensity of DNA bands. We can find out the amount of DNA in each band. The molecular weight can be analyzed according to the standards. So lot many operations can be done on gel documentation system. We have just shown a few.